Hi everyone, today's topic is some miscellaneous examples of aromatic and anti-aromatic compounds. So before discussing about the miscellaneous examples, firstly we will discuss about the characteristics of aromatic compounds. Aromatic compounds are cyclic, planar, follow Huckel's rule of 4n plus 2 pi electrons. Each atom is sp2 hybridized and sometimes it may be sp hybridized. They are stable, gives aromatic electrophilic substitution reaction and contains diamagnetic ring current. Their examples are benzene, naphthalene, anthracene, phenanthrene, cyclopentadienyl anion, tropylium cation, pyridine, furane, thiophene, pyrrole, etc. Now moving on to the characteristics of anti-aromatic compounds. Anti-aromatic compounds are planar, cyclic, contain 4 and pi electrons, less stable, possesses paramagnetic ring current. Now their examples are cyclopentadienyl cation, cyclobutadiene, aniline 16, etc. These are some common examples of aromatic and anti-aromatic compounds. Now moving on to some miscellaneous examples. First example is this. It contains 4 and pi electrons, but it comes under the category of non-aromatic compound. As oxygen atom is second period element, so it does not have vacant d orbital for delocalization of electrons. So it is non-aromatic in nature. Next example is this. As it contains 8 pi electrons, here we will count the lone pair of both the sulfur atoms for delocalization because sulfur atom is the third period element as it contains vacant d orbital for delocalization. So it comes under the category of anti-aromatic compound. So here 8 pi electrons are delocalized in the whole ring. So these are anti-aromatic in nature. Now moving on to the next example. Here we will count the lone pair of oxygen atom for delocalization, but lone pair of sulfur atom are non-countable for delocalization because as we all know oxygen is a second period element. It does not contain vacant d orbital for delocalization, so it is aromatic in nature. Next example is this. Nitrogen is a second period element. Its lone pair will delocalize in the whole ring including vacant d orbital of sulfur atom. So there are 6 pi electrons and compound comes under the category of aromatic compound. Next example is this. Here there are 6 pi electrons. As a lone pair of both the sulfur atoms will be counted for the delocalization because both contain vacant d orbital and hence it comes under the category of aromatic nature. Now moving on to the next example. Here there are 8 pi electrons. Now moving on to the next example. Here there are 8 pi electrons, so it is anti-aromatic in nature. Negative charge is also counted as the delocalization. So here 8 pi electrons are there. So it comes under the category of anti-aromaticity. Now moving on to the next example. In this example, as we can see that both the benzene rings are aromatic. Now we look at the middle ring. It is also aromatic just like previous examples. There are 6 pi electrons including lone oxygen atom. It will delocalize in the whole ring as sulfur atom contain vacant d orbitals. So whole compound is aromatic. So these are some examples, aromatic and anti-aromatic. Thank you.